Hello, you are welcome to another episode on Tom Makes Academy. Please kindly subscribe to our YouTube channel. Today, we're going to be talking about air. The natural gaseous constituents and their proportion in air. We're going to discuss about this. Learning outcomes. At the end of this lesson, learners will be able to define air. Tell the proportion of air constituents. Deduce reason for the variation in the composition of air in the environment. Identify the principle involved in the separation of air components. Starter video on air. You can watch this for further explanation. Air. Air is a mixture of gases. Air constituents are nitrogen, oxygen, carbon dioxide, water, noble gases, and pollutants. Constituents of air and their proportion. Nitrogen 79%, oxygen 20.9%, carbon dioxide 0.03%. Water, this is not constant, it varies, depends on many factors. Noble gases 1%. Also pollutants, this also varies. It depends on region and composition by volume. Now let's talk about the reason for variation in the composition of air in the environment. Man activities varies with regions, which tends to have effects on the atmosphere. In a region with low humidity, the air is dry, which results into low water composition. Also, in regions where industries are located, the pollutants in air is increased. Like where we have many industries, like many manufacturing companies, cement, oil and gas. So the pollutants will vary compared to an environment where there are no companies, no manufacturing industry, or few manufacturing companies. Principle involved in the separation of air components. Air is first compressed in a very small volume with pressure, then allowed to escape via a narrow opening. The energy to expand is withdrawn, causing air molecules to come together and become liquid. The component of the liquid air is then separated by fractional distillation. Test your knowledge. 1. Let's solve this question together. The approximate volume of air containing 10 cm³ of oxygen is? So students, can you attempt this? You should be able to attempt this. But if you can't, here is the solution on the slide. Question number 2. The properties used in obtaining oxygen and nitrogen industrially from air is? The property used in obtaining oxygen and nitrogen industrially from air is A. Boiling point, B. Density, rate of diffusion, solubility. The answer is A. Boiling point. So for question number 1 and 2, this is the solution. Solution to question number 1 and 2. Oxygen composition in air is 20%. Though it varies, though some textbooks will say 20.9%, some which say 21%. So let the volume of air be X. Let the volume of air be X. Then 20% of X equals to 10. That's the volume we are given in the question. So therefore, X equals to 50 centimeter cube. So note that the percentage composition of oxygen can either be 20%, 21, 20.9. Test each to see which applies to the question asked. So the question asks, we have to calculate the composition. Let's check the question again and look at the solution. The approximate volume of air containing 10 cm cube. The approximate volume of air containing 10 cm cube of oxygen, containing 10 cm cube of oxygen. So we are told that particular air is containing 10 cm cube of oxygen. So this simply means that 10 cm cube of oxygen. So I will know that oxygen composition in air is 20%. So since we do not know the entire volume of air, so we said let the volume of air be X. Then we now say 20% of X equals to 10 cm cube that we are given. Then make X the subject of formula. Then the volume of air is now 50 centimeter cube. I hope this is clear. The question number 2 is boiling point. Now we have come to the end of today's class. In this lesson, you have learned that air is simply defined as a mixture of gases. Man's influence on the atmosphere causes its variation in composition in different regions. Fractional distillation is the industrial process of separating air components. Assignment. Please do remember to do this assignment. Don't forget to do your assignment. It's very important. This will facilitate learning. So, thank you for joining us on Tomex Academy. We hope to see you in the next class. If you have not subscribed to this channel, please kindly subscribe to our channel. Thank you.